Hey guys, so second half of the week, like I said, we're going to start on graphing inequalities. And basically, I'm going to ask that you just write down this simple little table to kind of help you with it. So, with graphing inequalities, right, you are going to have your four symbols, less than or equal to, greater than, and then greater than or equal to. So, oh, here, you know what? Sorry. I'm going to go ahead and make doing a horrible job of this. Okay. All right. So, okay, so we've got our four symbols, right? There, like I said, there is less than or equal to, greater than, and then greater than or equal to. And those are going to be, it's going to be just like graphing lines before, but instead of having an equal sign, you'll have one of those symbols. Okay. And based on that, we're going to do different things with the graphs. So there is something called a boundary line, which is the actual line and the points that we plot. Now, if your symbol does not have a line under it, it's not or equal to, it is going to be a dotted line. So it's going to look like this, both of these. If it does have a line under it, so it's or equal to, it means that the boundary line is included in your solution set. So it is going to be solid, like that. All right. And then as we talked about when we graphed in linear inequalities on the number line, the solution to an inequality is any kind of number that makes the statement true. So there's like a whole bunch of different points that make the statement, like y is less than or equal to 2x plus 5. There's a bunch of points that make that statement true. So we are going to be shading the graph on the part where all of the points are that make it true. Like how on the number line, we would go left or right. We would kind of shade the number line. Now we're shading the whole graph. So the way to tell is that if it is less than or equal to, like less than or equal to, you shade below the boundary. And if it's greater than or equal to, you shade above. Okay, so that's really the two things you need to look at. Is it above or below, and is it solid or dotted? Okay. So graphing these is going to be the same as before, right? Where M is 2/5 and B is 4. That part has not changed. So I'm going to make a dot at 4. And then I'm going to go up 2 and over 5. And then because, especially with inequalities, it's good to go over the whole graph, I'm also going to go down 2 and left 5. Now in this case, my symbol is less than or equal to. It has the line under it, so that means it is a solid line for my boundary. Then it's less than, so that means that I'm going to shade below. Everything below the boundary line. So that means that any point in here would make that statement true. For example, if I picked the point 5, 1, and I plugged in 5 for x and 1 for y. And I said 1 is less than or equal to 2/5 times 5 plus 4. Then I'd be saying 1 is less than or equal to 2 plus 4, which is 6. And, oops, I wrote, anyway. So, is 1 less than or equal to 4? Yes, it is. For crying out loud. So, and that'll be true for every point in the shaded area. They will all make this statement, or the equation true. So, for this one, same thing, m and b. M is negative 5/2. B is negative 1. So that means that I start at negative 1 on the y, and since it's negative 5/2, I go down 5 and right 2. And then I'm going to go up 5 and left 2. Now my symbol is just greater than, so that means that I'm going to make a dotted line because there's no line under it. Okay, so it's going to be, there's a horrible dotted line. It's a little better. Anyway. All right, now sometimes with these steeper lines, it's hard to tell which side is above and which is below. So just think like if you had a little stick person, if they're above it, they'd be able to like stand up on that side. If they were on the other side, they'd be hanging off of it. Okay, so just that's the best way I can think of to think. So I want it to be above. So I'm gonna do this side. You can't always say like left or right or anything. It has to be above or below. So there you go. Every point in that shaded region is going to make that statement true. Okay, excuse me. So last thing, I did just kind of want to remind you guys about why, when it's just y and just x. So if you have y and a number, you go where that number is on the y-axis, and you're just going to go straight across. Okay? It's a solid line because it's got the line under it, and it's greater than, so that means that I'm going to shade above. All of those points make it so that y would be greater than or equal to negative 1. Oh, crap, negative 1. Oops. I did 1. It's supposed to be down here. There we go. But everything else was the same. I just messed up on that. Sorry. Okay. There we go. All right. On this one, we got x is less than 4, so that's going to be a dotted line. And I'm going to go where x is 4 and just make a dotted line that is vertical. Just think of it how we're used to. Most equations are y equals. So when you have one that's x equals or x, inequality symbol, that's going to be the different one where it's vertical. So because you can't be above or below a vertical line, you just have to think if it's less than, it's to the left, right? Look at where the x's are less than 4. So, oops. So all this over here is going to make that true. All these points have x's that are less than negative 4. Sorry. Kicking the cord and it's pulling my computer. So anyway, that is kind of like our intro to graphing inequalities. We're going to kind of take our time with it, make sure everybody feels comfortable with it. But at the live meet, we will be going over more examples.